Welcome back. This is Mr. Greenstein's Geometry, and we're in Chapter 6, Section 6, Inequalities in Two Triangles. So we're going to look at what's called a trapdoor. A trapdoor is on the floor, and there's a hole in the floor, and the door is covering that hole. And the door pivots up from the floor on a hinge. So here's the hinge. The door length doesn't change, and the hole in the floor doesn't change. But as we open up the door wider and wider, then the length of this gets bigger too. So this length gets bigger, and this angle gets bigger. We have a name for this situation where the two sides of this triangle stay exactly the same, but the third side gets bigger. We call this the hinge effect. And the hinge effect says two sides of a triangle stay the same length, but the third side changes, this side and this side. If the included angle gets bigger here, then the third side length gets longer. Kind of makes sense. So let's take a look at this situation. I have this length here, JK, and KL are of the same length. And then I've got KM, which is the same for both triangles. So these lengths don't change. I have different angles here. So this angle is greater than this. So which is greater, JM or ML? Well, using the hinge effect, we can see that this angle is greater, so this has to be longer than this is relative to the 61 degrees. So JM is the longer side because of the hinge effect. Hinge effect says that if two sides of one triangle are congruent to two sides of a second triangle, and the included angle of the first is larger than the included angle of the second, then the third side of the first is longer than the third side of the second triangle. We also have the converse of the hinge theorem. If two sides of a triangle are congruent to two sides of a second triangle, and the third side is longer than the third side of the second triangle, then the included angle of the first is larger than the included angle of the second. That's the converse. So the hinge theorem says something about the sides and the angle, and then concludes about the side. The converse says that we talk about all three sides, and we conclude with the angle. So here's a problem. Two biking groups leave camp at the same time. So we have one group that goes 2 miles in this direction, and another that leaves camp and goes 2 miles in this direction. Group A is going to make a 45-degree turn in this direction and continue 1.2 miles. And Group B is going to make a 30-degree turn and go in this direction 1.2 miles. Now, which group is farther from the camp when they get finished with that? Well, Group A is going to go 45 degrees here, so this is going to be 135 degrees in this angle here. But for 30 degrees, this is 150 degrees in this hinge. So this means that this distance is going to be greater than this distance here. So Group B is actually going to go further in this scenario than Group A. And we use the hinge theorem to come up with that solution. We'll discuss this in the next time we get together in class.